Alright, here we are, Chapter 7. You guys are seeing the light at the end of the tunnel. It's getting close, almost over. And we're going to be talking about actually all kinds of stuff, but constructors are our main focus, and constructors are kind of weird. Some people understand them right away, and other people it's like, why is that there anyway? So hopefully we can fix it so that you guys all understand a constructor. But before we get into that, let's back up a little bit. We just talked about classes. And the book had mentioned the get and set commands. And I want to talk about those a little bit. Now, technically, get is an accessor, and set is a mutator. Again, that's just technical stuff. We don't ever really use that day-to-day stuff. But the command get is used to return the current value of a variable. And set, obviously, is used to set the value of a variable. So it sounds nice and easy. But what they're used for, in your classes, we typically have private variables. Well, we might need to manipulate those in the main program. So in order to do that, we need to use get and set to manipulate private values. So in a class, you'll see something like this. Now, this next three examples I'm going to show you are a program to where the user puts in the length and the width, and then it multiplies them and gives you the area. So they made a class, and the class is called rectangle, and it's got two private variables, length and width. So remember, private variables are only allowed to be manipulated through the class, or functions in the class. So only by stuff in the class. They cannot be manipulated by the main program, if that makes sense. So what we're going to do is we're going to make four small functions, two of them to set the width and set the length, and then two of them to get the width and get the length. And we can use these, because these are public variables, we can use these in our main program. So that's where get and set get their utilization. So they allow us to manipulate private variables inside the main portion of our program. So what would those functions look like? So again, set width just sets the width to W. Set length just sets the length to L, or makes the variable L. So you get the idea. And then get just returns the width or returns the length. So this way I can call in the main program, set the width to 5, and it will set width to 5. I can't just say width equals 5, because width is a private variable and can't be accessed in main without being a part of a function that was in the class. So that's why I need to do that. And to kind of see this thing, so my class is called rectangle. But remember, each time we make a class, when we use it in the main, we have to have different instances of the class. Because I might have a class that gathers user information, first name, last name, things like that. So I might have 20 instances because I have 20 people recorded. So I have to give it like an instance. So this version of class we're going to call my rectangle. And we're going to have one length and one width. So these are separate. Remember that length and width are private variables in the class, but one length and one width are regular variables we can use in our main program. And then in this case, she initializes them to 0. Alright, and then you get some output to the screen. This program will calculate the area of a rectangle. Please enter the length and width. And then when they enter the length and width, it becomes one length and one width. Alright, and then in order to use the set, we have to call the instance, and then the dot operator, and then set length, so we're calling that function, and then whatever L length is, that's now going to become length. And then whatever L width is, that's going to become width. So we've taken these two values in the main program, and we've transferred those values to length and width, which are our private variables in the class. And then we use something to multiply length times width. So we say, hey, get length, get width, and then we multiply those two together, and that gives us the area of the rectangle. So set allows us to set a variable inside main to a private variable in the class, and then get allows us to pull those variables out and use them. Now, it sounds like a lot of work, and something small like this, it absolutely is a lot of work, and it's way more extra than you need. But in bigger programs, when you have multiple, you've got several classes, you've got multiple instances of the class, and you want to keep some information private so it can't be found, we have to use get and set to manipulate those variables. All right, if for some reason that's not clear to you, there's like a small 10-minute video where somebody on YouTube, a woman, and then the volume's kind of a little bit weak, so you have to kind of turn it up. But she goes through this example and she explains the set and the get and the why and mutator and accessor, blah, 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 that kind of stuff. So if you have an issue, make sure you watch that 10-minute video. Just call it, I think it just says get and set example or get and set, something like that. But it's in this week's folder. All right, so that's enough of the old stuff. Let's go to new stuff, constructors. All right, a constructor, the technical definition is, it is a member function that is called automatically when an object of the class is declared. Well, what the heck is that? Well, another way to put it is you want something to run automatically, or you want to add default values to items is typically where it's used. And I know that probably doesn't help you either, but they're typically in the public section. There's really no purpose of putting a constructor in the private section. All right, really, constructor in the real world, it's just a special function inside a class. Remember, our classes can have public and private members, and we can put functions inside the class as well. Well, a constructor is a special function inside a class that runs automatically. It must have the same name as the class, and it does not have a type listed to it, which is kind of weird. So at this point, if you've never seen a constructor before, you're like, what the heck is he talking about? All right, here's an example. So I create a class, day of the year, and then inside day of the year, I have 3 constructors. I have day of the year with 2 values, day of the year with 1 value, and day of the year with no values. And then I have my regular functions, void input function, void output function. Notice there's no type here. There's no void, there's no integer, nothing like that. So there's no type with it. And it also has to be called the name of the year. Or I'm sorry, it has to have the same name as the class. And what happens is, again, that runs automatically when classes run. So again, let's say for some reason you have a program that is going to show somebody, like this week's calendar. Well, you'd want the program automatically to, when it starts up, to pull today's date and then use that week. You don't want the user to have to punch in the date, hey, here's today's date, show me the week. I mean, how useless would that calendar be? So you want a calendar that as soon as the user opens it, it opens up to this week. So by having that in a class, when the class is run or read, it automatically initializes the day of the calendar, whatever, to today's date. Then it would always know what today's date is. It just pull it from the the windows, without the user having to interfere with it or put data in. So that's where we see it. We see it to initialize variables that we can pull from other places we typically might not need from users. All right, and again, we can overload that. Remember, overloading just means having multiple names of the same thing. So I have day of the year, day of the year, day of the year. But something has to be different if all 3 can't share the same name if they're the same. So the difference is this one has 2 values, this one has 1 value, and this one has no values. So in summary, it has to have the exact same name as the class. It does not have a type, runs automatically, and then there's always a default constructor. Whether you create a constructor or not, one is always made by default. That's where it gets weird. And you'll always see this constructor like day of year, nothing, that is created automatically. You might not see it, but it is always created if you don't create a constructor. So at this point, when you guys are creating your classes, we've never seen it. But one was always created kind of in the background. Your class has to have a default constructor. So if you don't create one, it creates one automatically. And then again, you can put everything else in your class. Now remember, inside your class, you have members. And those members can be public and private. If you have a variable that's not a member of a class, then it's just an object. So again, we get into the terminology, but remember, I didn't make the exams for this class. So when you get into the exams, they tend to use some of this terminology, which is why I sometimes throw it out there, letting you know that you might see that on the exam. All right, so moving on. So, I made this constructor. Hey, I got 3 constructors, one with 2 values, one with 1 value, one was just the default with no values. How do I add those values in there? Well, now in the main, you can just do day of the year, and then you can create date 1 and just put in the values, date 2, put in 1 value, and date 3, put in no values. And then if I say, hey, show me the dates, it would say, date 1 output, and then this would show you, February 21st, May 1st, and then whatever the default date is, January 1st. So that's how you add values to the constructor. So constructor is asking you for 2 values, a month and a day, and then you can just, if you want to send it out to the screen, you do output, but to initialize it, day of the year, and then give it whatever that instance is, and we're going to call this one date 1, and it's going to be 2/21. Now, in addition to that, you can actually make full-fledged functions in the constructor. So here would be a function day of the year, and then month and date, and then I have a second line that kind of indented over to the right with a colon, where I can do month value, and day value, and that's the entire function. So this second line of code is called the initialization section. And then we can add code to the function, like if you, on the 6th edition of the textbook, look at page 285. All right, and I think I'll do an example of this when I do the example portion of the video. All right, moving on. Remember, there's always a default constructor, and a default constructor just means it's a constructor with no arguments, so there's nothing in the parentheses. If you don't create one, one is automatically created, so there is always a default constructor in a class. But it is good practice to always make one, that way you can see it. And if you see it, you know it's there, and it can be manipulated later on if you need to. But if you don't see it, you might forget it's there and may try to do something another way that would have been easier if you would have used the default constructor, if that makes sense. All right, so let's actually see how a constructor is used in the code. All right, here's a first example. So, I got my stuff at the top, and then I have my class, the day of the year. And then I've got my 3 constructors, day of the year with 2 values, day of the year with 1 value, and day of the year with no values. So that way I can decide which one to call. And remember, if there's not a value, it'll default to 1. And then I've got my functions. I have void input, void output, and then I have get month number. And get month number allows me to, when I put in 1, it'll return January. And if I put in 2, it'll return February. And that, because that's kind of the easy one, is just done here with switch. So 1 becomes January, and then it breaks out, or if I put in 2, it becomes February, and then it breaks out of that. So you get the idea. All right, and then I've got some private, the date, the month, and then test date. Now, test date is used to test the input to make sure that the user put in a number between 1 and 12. All right, now let's see how it's used in the code. So in my main, I input day of the year and say, hey, here's your data. So I'm going to have 3 dates, date 1, date 2, and date 3. So date 1 is going to be 2/21, which is going to go to February 21st. Date 2 is going to go to May 1st, the default value. And then date 3 is just going to go to January 1st. And then I'm going to initialize the dates. That's going to say, hey, initialize the dates. And then it's going to show you the dates. So if I want the constructor to output those dates, I got to go date1.output. And remember, output is a function here. And if I go look at output, that's where it grabs the month, and it says, well, if you're 1, then be January. And then it outputs the day, just as a day, the 21st, 22nd, 23rd. So that's all output does. So going back to that. So date 1, take the date and then put it in output and run that function and come back as, February 21st, and then send it out to the screen. All right, and then I change date 1 to 10/31. And then I put out to the screen, hey, date 1 has been reset to the following. Date 1, run the output command, da-da-da. All right, and then whenever day of the year is accessed, you can see test date. This function calls this function. So day of the year then calls a function called test date. And if I go to test date, it's right here, and it just says, hey, if month is smaller than 1 or greater than 12, send out illegal month value. And if day is smaller than 1 or greater than 31, do illegal day value. Now, obviously, this isn't coded enough to know that February is only 28 days and things like that, but it's just a general way of checking the data. So let's see what happens when we run this code. All right, so it spits out the 3 dates. Let me go here and line this up for you. So here it says, hey, give me the output of date 1, output of date 2, output of date 3, and then here are the values that we put into those. So those become February 21st, May 1st, January 1st. And then date 1 is reset to the following October 1st. Now, what happens if I put in a wrong value? Well, let's change that. Let's say I put in the month as 13. And then I try to run the code. You know, as soon as this first one tries to go, it's saying, hey, this is illegal output, and then the program dies, or it kicks out. And then that's where that exit comes in. So if it is less than 1 or greater than 12, exit the program. And that's why it stops there, instead of letting the user put in more values. So again, I can change this to anything. 5, run the code. And then it becomes May 21st. But you get the idea. So that's how the constructors are used. Now, I'm not going to go into too much more about constructors with the examples because I'm not going to ask you to do a lab with the constructors. Now, next semester, or when you take the advanced C++ course, they get into these constructors again. So make sure that you have this information. What I'm going to do is I'm going to take 2 or 3 examples of the code here with constructors, and I'll put them into a text file, and I'll put them in your folder, and that way you can kind of keep them, and then right before the advanced class you can kind of refresh yourself, and oh, hey, that's how constructors work, or that's how I use them. But other than that, you've got enough now. You understand what a constructor is, and you understand how to call the values in the constructor. All right, here's another example real quick. Just I want to point out one last thing. When we're using classes in functions, we give them the double colon. I don't know if I mentioned that last week. So here, when I create the functions, you see the double colon, the double colon, the double colon. So just make sure you're aware of that. And typically you get the same name over and over again, holiday, 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 holiday day of the year, or day of the year, that kind of stuff. But sometimes you see something different, holiday and then output. But in the name of a function, we typically use the double colon. All right, so again, I will put samples of these in your folder, and that way they'll just be text files, and you can just cut and paste them into your Visual Studio, and you can kind of check them out later on. But again, don't get too worried. This is just extra information to help you. There is no lab on this stuff this week. All right, moving on. Blah. So, a couple things for your exam and the stuff that I have down. Every class has a constructor, whether you create it or not. There's always a default constructor. You might not see it, but if you did not create one, it'll create one for you, just won't be used. All right, when we see code like this, date1.output, date1 is the object. Remember, your variables can be objects or they can be members. And then this is what they call the dot operator. And then we have the data member. Remember, output says, hey, call this function output. But we call that the data member because it's going to give us the data to put in there. Or it's going to output it's going to do something with the data. So make sure you're good with the terminology. Object, dot operator, and then data member. All right, and I keep saying this wrong. I keep saying that your variable is an object or a member, but I'm sorry, I mean to say an object is a method or a member. It's either a method, a way to do something, or it's a member of something. So it's a member of a class, or it's a method of a function, something like that. So make sure you're good with that line there because you may see that on the exam. An object is a method or a member. All right, and then an object can handle different types of data and treat them as a unit. You know, I can have an object that has a double and then an integer and stuff like that. So I can have a function which could be an object. All right, when I use one constructor to call another constructor, we call that delegating constructors. So when one constructor calls another constructor, we are delegating constructors. And then the default return value of a constructor is none. You know, by default, the default constructor is made. It has no arguments, and it does not have a return value, or it has a default return value of none. There is no return value. So it's not void, because void says don't return anything. It's just none because there is none, if that makes sense. All right, moving on. So members of one class, or a constructor of one class, can be a member of another class. And you'll see this on page 298 of the 6th edition. So here I have a class, day of the year, and day of the year has some public and then some private variables. And then I have a second class called holiday, where day of the year, the other class becomes a member of holiday. So one class or can become member. Wow, I'm really tearing this up. Constructors in one class can become members of another class. All right, so inline function definition. When you give the complete definition of a member function within the definition of its class. So I create a constructor and then give its function definition in the class. They call that an inline function definition. So the entire thing is created all contained inside the class. It's not like the other one we looked at where we created the constructor in the class and then the functions were outside the class in the, outside of main somewhere else. But everything is contained inside class. We call that an inline function definition. So in this case, bank account, balance, and rate, and then we have the function double, get balance, blah, 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 return to, you get the idea. All right, so we're all done with constructors. Constructors are nice. Again, they come into play in some areas. For smaller programs, the things that we typically write ourselves. They don't have a lot of use because you can do things more efficiently other ways. Especially like if you watch the video with the, sorry, wrong one. I'm thinking something different. Oh, no, I'm not. If you watch the 10-minute video on the rectangles, she shows you at the beginning how she wrote the code with like 8 lines of code. And then when she adds a class and adds the constructors and stuff, it becomes like a giant, 40 lines of code thing. So on normal stuff, you won't be using constructors an awful lot, but you need to understand them because you're going to see them in other people's codes and you'll see them in bigger programs. Now, vectors. Vectors are much cooler. If you're getting into game design, if that's your major, vectors are going to be very important to you because we use vectors a lot in game design. A vector is like an array, but unlike an array that has a static size, a vector can change its size as the program runs. So let's say you've got a vector with 50 items in it, and then all of a sudden the user, sells 25 items out of his inventory. You no longer need to keep those extra 25 items stored in memory. So you can make the vector smaller and shrink its size to free up memory. So it always has a base type like an array, like integer or double or something like that. So it's a lot like an array, but it's a resizable array. And that's why we like it for game design. We like to free up as much memory as possible for other things in our games. So it's written as vector and then a type and then a name. So you would see something like vector, integer, or double, or character, and then a name, game stuff. And then that would be your vector. You'd have a vector called game stuff that in this case would be a double. Now just like an array, they're indexed starting at 0. So a 5-element vector would be numbered 0 through 4. And we can add elements to a vector by using the command pushback. Pushback adds 1 element to the end of the array. So if I have an array of size 5, 0 through 4, and then I do a pushback on it, it will then open a 6th element, or number 5. So here's an example of a vector. So note, it is not included in the standard library or anything, so we have to include vector. All right, and then we create the vector. Vector, it's going to be an integer, and we're going to call this v. And then we input some information, and then we say, hey, v, pushback, add an element, and we're going to add whatever the user put in. So here we create a vector of size 0 with nothing in it. Then we tell the user to input positive numbers until they input a negative number, and then it'll kick out. So when the user puts in a number, we're going to call that number next. So it goes into the program as next. And as long as next is not negative, run this. So then the vector gets space added, and it adds the value the user put in. And then that value shows on the screen as added, and then it shows you the new size of the array. And then it shows you, hey, here's again, the number that they popped in. And then once they put in a negative number, it's going to say, hey, you entered, and then it's going to pop out all the information, that kind of stuff. So that's a vector. A lot more useful than an array, especially for video gaming, because, again, memory is huge. We want to keep track of memory. We want to free up as much as possible. So vectors allow us to shrink and grow the array as we use it. If you get into Unity and you start doing some game design in there, as you're watching people do scripts or you're learning scripting in Unity, you will see vectors used a lot. All right, so to add elements, so I can just do, so I create a vector. Vector is going to be integer, and it's going to be called sample. So sample, pushback, add 5. Sample, pushback, add 1. Remember, the new element is added to the end of the vector. So if I have a 5 element, 0 through 4, the next one I pop in is going to go be element number 6, or number position 5, and then position 6, position 7. So it doesn't start adding at 0. All right, and then you can also resize a vector. So again, I create a vector. Vector going to be integer, and I'm just going to call it v. I can resize two different ways. I can do v resize to 24, and that says, hey, you are now going to be size 24. Or I can do reserve 32, and that would reserve 32 bits of memory for that thing. Or I could do something like reserve whatever the size is now, add 10. And that way, if I don't know how big it is, but I know I'm about to add 10 items to it, I can just do, hey, size, add 10. So you can see there's a lot of neat ways to manipulate a vector and change the size. Make it shrink, make it grow. Whatever you're doing in the game or the code, you can change the vector to accommodate that. So again, there's that example again. So remember, pushback only opens up one hole. It opens up one extra element in there. You have to use resize or reserve to create different sizes. If my current array or vector is 50 and I want to make it 25, I can just do resize 25 and shrink it down. Or I could do resize 75 and grow it by 25. So a lot of functionality there. All right, that's about it. Remember, there is no lab this week on this chapter. But you need to understand the get and set commands we talked about earlier, understand how constructors work, and then how vectors work. Because when you go into the advanced class, they're going to assume that you've seen this stuff. And if you walk in there, oh, I don't know this stuff, they're going to be like, well, maybe you need to go back to JMAX class. And you don't want to do that. One JMAC class is enough for most people. All right, so that wraps it up. Again, if you have any questions, make sure you email me, post on the discussion forums, whatever it takes. I check my email and stuff every day. I'm in there like, oh, how come nobody's emailing me? That kind of stuff. You get the idea. So this week, I think you've got the exam review sheet, and you've got something else. I have no idea what it is. So I thought you have 2 items to do today. The exam lab. The exam lab opens this week. So really you have all this week to kind of get that. And then you have the exam review sheet. There's also a homework file in there if you want to play with it. And this time I put the answer to the homework in the materials folder if you notice it. And again, that might help you to study for the exam. Remember, next week is the exam. I think there's 21 or 21 multiple choice questions, and then there's like 5 or 8 essay questions where we ask you to explain something. What does a vector do? How is a vector different from an array? And then in your words, you'll kind of put that out there. So make sure you're ready for that. So you should have your book all nice and annotated, whether you're using highlighters or using Post-it notes all over your book on certain topics. So you have your notes getting all set, your previous quizzes, exams, all the other stuff, and have it all ready. And that way when you take the exam, it's nice and easy, and you pop it out, and you're all done. All right, so again, questions, email, discussion forums, let me know, guys. Thanks. Have a good one.